Assalamualaikum warahmatullahi wabarakatuh, and very good morning or afternoon to our fellow classmates and our beloved lecturer. So, today our group will be introduced to you guys about one type of hydrocarbons, which is alkenes. So, before we starting our introduction or presenting, I would like to introduce you to our group, which is me, Muhammad Razif bin Norman, and Muhammad Nakib bin Razali, and Khairul Faris bin Khairul Azri. So, the first thing, what is alkenes? So, alkenes is an unsaturated hydrocarbons that different with alkenes which is saturated, which alkenes is unsaturated hydrocarbons that contain one or more carbon-carbon double bonds in their molecules. The general formula of the homologous series of alkenes with one carbon-carbon double bond is CnH2n. So, they have a picture that provided by us that show the formula structure of alkenes. So, in this video, we will talk about how to naming of alkenes and types of alkenes. And in this video, we provide three, which is alkenes with one double bond, second one alkenes cycloalkenes, and the third one is isomerism in alkenes. So the first one, we will talk about the alkenes with one double bonds. So the step one, name the parent hydrocarbon. How to name it? The first one is we need to select the longest continuous carbon chains that contains the double bond. Name of alkene is derived from the corresponding alkene by changing the suffix from "-ene" to "-ene. Such example, pentane, which is alkane, which is contain 5 carbon atom. In this alkene's nomenclature, it will become pentane. So the same with hexane will become hexene. So step 2, indicate the position of the double bond. The carbon atoms in the chain are numbered so that the carbon atoms with the double bond have the lowest possible number. And the last step is name the substituent and indicate their position. But take note, position of C double bond is of higher priority than substituent. So we move to the next part, which is alkene cycloalkenes. So the step 1, replace the "-ene" ending of the cycloalkane having the same number of carbons by "-ene. As example provided, when we have hex to "-ene, it will become cyclohexene. Typo, cyclohex to "-ene. So when we do a pentene, it will become cyclopentene. That's all. For the step 2, number through the double bond in the direction that give the lower number to the first appearing substituent. Take note, the priority between alkyl and C double bond, the alkene is a functional group, therefore the priority here given to C double bond. And we move to the last part, which is isomerism in alkenes. They have two types of alkenes isomerism, which is the first one is structural isomerism and the second one is geometric isomerism or cis trans. As example provided, we will look to the structural isomer, and the examples state that 1 butene and 2 methylpropene under this category, when cis 2 butene and trans 2 butene under geometric isomers.
Okay, next I will explain about physical property of alkene. The physical property of alkene are similar to that of the alkene. However, alkene has slightly lower melting and boiling point than corresponding alkene. As shown in the table, the boiling point increase as the carbon chains become longer. For example, 18 has a boiling point of negative 104 Celsius, while 1 butane has a higher boiling point of negative 6.3 Celsius. This is because larger molecules have a stronger intermolecular force. Okay. Solubility soluble in non-polar solvent and not soluble in water. In property vary based on chain size. Alkene also have weak van der Waals force between molecule. For example, the lower carbon alkene exists as gases at room condition. Okay, alkene with several double bond will have a color associated with them. Okay, next I will explain the chemical property of alkene. Alkene are reactive because they contain a carbon double bond. They mainly undergo addition reaction. There are four important addition reaction. So the first one is hydrogenation. Second one is addition of hydrogen halide. The third one is addition of halogen, and the fourth one is hydration. This reaction make alkene useful in many chemical industry. That's all for me. Thank you.
First is the degree of substitution. Alkenes with more alkyl group attached to the carbon-carbon double bonds are more stable. Therefore, the stability order is tetra-substitute, followed by tri-substitute, di-substitute, and finally mono-substitute alkenes. Second is stereochemistry. Trans-alkenes are generally more stable than cis-alkene because the larger group are located on opposite side of the double bonds. This reduces steric repulsion between the groups. Third is conjugation. Conjugated alkenes are more stable than isolated alkenes because the electron can be decollized across multiple double bonds which lower the overall energy of the molecule. Starting with ethene, ethene is widely used to produce polyethylene through polymerization. Polyethylene is used in plastic bag, packaging materials, and children's toys. Ethene is also used to manufacture chemicals such as ethylene glycol, which is used in antifreeze, ethanol, and vinyl chloride, the raw material for PVC production. Next is propene. Propene is polymerized to produce polypropylene. Polyethylene is used in kitchenware, molded containers, and medical equipment. Propene is also an important chemical intermediate for producing acetone, isopropyl alcohol, and polyethylene. Finally, the higher alkanes have many industrial applications. Some are used to manufacture synthetic rubber for products such as tires and industrial belts. Launchings alkene are also used in production of detergent and surfactants that are commonly found in cleaning products.